Okay, hello students. Here I would like to make a video on lesson number 20. And here it is. Uh, Lesson number 22. So let me go directly to the problems solving rational equation. So, so how do we solve the first problem is, I can see you use the cross product. So you can, now there's a x here and this is x minus 2. So one way to do is you write the same thing 2x plus 1 and x equals 1 over x minus 2. So the denominators are x and x minus 2, and that's what you're going to multiply x as well as x minus 2 on this side, and you also multiply uh, x and x minus 2 on this side. And now we can cross it out and say, okay, so this x and this x goes away, and this 2 will remain. And here x minus 2 goes away. And now you use the distributive property. So this is x minus 2 and 2x plus 1. And the right side is just the x. Now you can use either box method or FOIL method and put, okay, this is x minus 2. And the other one is 2x plus 1. And this will be 2x squared. This will be x. This will be negative 4x squared. And this will be minus 2x. And then 2x, I think there's one thing, oh, this number is just multiplying 1 to minus 2 will give you minus 2, and this you can combine. So this left side becomes, the 2x square will remain, 2x square. This thing will be, this diagonal total sum will be minus, this is x here. So minus 4x and plus will give you minus 3x. And this is minus 2. And then we subtract x both sides. So everything on the left, so you get 2x squared minus 4x minus 2 equals 0. And then you can say divide by 2 because you can still reduce it, and you get x squared minus 2x minus 1 equals to 0. Now there's a 1 here. When you have this 1, so 1 is 1 times 1, right? But there's a minus 2, but if you subtract, because there's a minus, you think of subtraction. So we cannot factorize this, so we'll have to use the quadratic formula. So what is the quadratic formula? So if this is the case, we need to use the quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a. If you look at this, the 1, a is 1, the b is minus 2, and the c is minus 1. So you plug in right here. So this becomes x is minus plus minus square root. The b is put here, which is minus 2. So I'll put minus 2. b again minus 2 square. And then 4 times a is put here, which is 1. And c is minus 1. And then 2 times 1. So this becomes x equals 2, negative makes it positive 2, and the inside. So this becomes 4. This negative and negative become positive, so plus 4 and 4 become 8. So that you can put it inside 8 here. Okay, and what is square root of 8? Square root of 8 is square root of 4 times 2. And if you separate this, becomes square root of 4 times square root of 2. So this becomes 2 root 2. So you replace the red color by that. So this becomes 2 plus 2 root 2. And there is a down 2. So that 2 in the denominator crosses out with 2 divides to 1 times 2 also here. So you get 1 plus or minus root 2. So your two answers are one with plus and the other one with minus, and you're done. So really long work here. So many steps are involved, but that's how it is beautifully solved, the two rational equations. Okay, the next question is B, the new problem. Now, in this case, instead of multiplying the x plus 2 and x minus 1 both sides, better to do use the cross product. So that way it becomes faster to do. So it is 1 into x minus 1 equals 2 into x plus 2. So this will be the 1 does not affect this parenthesis, stays the same, but here use the distributive property. So that will be 2x plus 4. Now we solve for x's. So you can subtract 2x here. So that way this is 1. So minus 2 and plus 1 is minus 1x. Drop down the minus 1. This cross it out, we get 4. Then add 4, add 1. That way you get minus 1x equals 5. And then divide by minus 1 and get x equals minus 5. So that's the solution for the problem. And you can also sketch this. If I have draw x-axis and the y-axis, what does this 1 over x minus 2? So you can see there is a vertical asymptote. You can't have x equals minus 2, right? So that means suppose this is negative 2 here. So there is a vertical asymptote for the first rational function. Okay, and then there is the other one. So what is how does the graph look like this of this one is because there's a one here, the x-axis becomes the horizontal asymptote, and the uh, y-intercept. So where does it cross? Suppose you want to know where does it cross the y-axis, you put x equals 0. You see in this case you get half. That means you know it's going to be half going this way, and this is the graph will look like. So the graph would be going something like this. It goes like this, and then this side goes something like this. So that's the first one. So let me draw it nice and neat here. So this is. What about the second one? This 2x minus 1, and you can see here the denominator becomes e0 if it is x equals 1. So this becomes the vertical asymptote. So we have to draw another at 2, at 1 we'll have to draw 1. So this is 1, there's one thing like that. So it is 2 and x minus 1. So that means the graph. So here also you can say 2 over x minus. So the numerator it is x raised to 0. That this is 0 and there is a 1. So there is a horizontal asymptote which is just the x-axis, which is the y equals to 0. That means this is again the horizontal asymptote for the second one. So the graph would look like something like this. So let me use the green, some other color maybe. Okay. So something like this. Right? It goes like this, but then other side it crosses at maybe. See the answer that we got is minus 5. So it's like if I put x is 0 here in this equation, if I put x equals 0, so you get x becomes 2 over minus 1 is minus 2. That means this is minus 2. So that's it. It goes through this. Okay, and then somewhere it crosses this point maybe here. See this part? So this is that minus 5, which is I'm talking about is where they meet here. So minus 5. So if I put here minus 5, x is minus 5 here, it is 2 over minus 5 minus 1, which is 2 over minus 6, which is minus 1/3. So somewhere here they cross at this minus 1/3. So they cross somewhere here. So that's the understanding of the green graph. Uh, so this is the green graph, and so let me make it nice. And so the green graph and the pink graph they meet each other at this point. So I hope that makes sense. Not just solving the problem, also trying to understand how the graph looks. So the question number C, the third one, I would just do cross product like this. So this is the best option. And when you multiply, you get. So let me clean this. So when you multiply, it becomes x plus 3, and then you times x plus 2 equals 1 minus x. So this is the product, and you can use the distributive property. So, and you can either use the FOIL method, that means first, outer, inner, last. So x times, so when you multiply x times x, it becomes x squared. Then x times 2 is plus 2x. Then you multiply the inner, which is 3x, and then you multiply this one, becomes 6. Same thing you do, 1 times x is x, then 1 times 1 is 1, then x times this is minus x squared. And this is how you can do. Or if you get confused, then you do the box thing and you just put, okay, x and 3 and x and 2 here, and you work out and you get the answer. Same thing you can do box also. Now, so now there's x squared here, there's x squared here. So what I'll do, I'll get the everything on the left side. So add x squared, and at the same time you combine the numbers. So this you combine, so that way this becomes 2x squared, this becomes plus 5x, this is plus 6, and the other side this goes away, you get x, and this goes away and you get just not x itself, and then subtract at this side. So that we get 2x squared plus 4x plus 6 equals to 0, because this is minus 1. So plus and minus 1 is plus 4, and you can see there's a 2 which divides all of them. You can still reduce it to small and you get like this here. Then we can split this 3 as 3 times 1. Remember, 3 times 1 is 3, and 3 plus, and you can see 3 times 1 is 3, but there's a plus 3. So what does plus 3? That 3 and add up, well, 3 and 1 add up to 4, but there's no 4 here, so we cannot use this. But the question is, can we use the quadratic? If you show this b square minus 4, you see, inside a radical sign, you cannot have negative. So we need to know what is the discriminant. So what is that discriminant here is, this whole thing is the discriminant, D. I call it a discriminant. So in order to have two graph meeting, then there has to be a real solution. So b square minus 4ac, if I write b, so b is plus 2, so 2 square minus 4 times 1 is, a is 1, so I'll put 1, and times c is plus 3, so that is 3. And if you see, this will become 4 minus 4 times 2 is 12, and that is negative a, and this is less than 0. So the moment we have less than 0 means the inside part, this will be negative, and that's why we say there is no real solution, no real solution. In other words, the two graphs, whichever that they gave you here, see this, there are two graphs. This is one graph and this is one graph, and you can, if you put this on the desmos.com, each equation on separately, put y equals the first one, put y equals the second one, and they never cross each other. So that's why there's no solution for. Uh, Look at this. This one, you can do the same thing, use cross product. So x plus 2 and x plus 2 is multiply itself. And then 1 is, anything multiplies to 1 to the denominator, x plus 8 will remain the same. And the left side, you can use FOIL method. X times x is x squared. X times 2 is 2x. 2 times x is again 2x. And 2 times this is 4. And combine this, you get x squared plus 4x plus 4 is x plus 8. You can do two things here. You can subtract x, and at the same time, I will also subtract 8. So two step in one. What are you getting is x squared. This is minus 1. So minus 1 and plus 4 is this, 3x. This will be negative 4, and this is 0. And now the question is, what is the solution for minus 4? So if you see, we can't, 4, oh, there you can do this. The 4 can be written as 1 times 4, right? So 1 and 4, if you subtract, does give you 3. So that means there is a plus 3 here. So you need to have two factors here. So x and x. So negative 4, uh, 1 times 4 is 4, and positive 4 and negative 1 gives positive 3, which is there right here. So we can use this to plus 4 and minus 1. So this is called factorization. So there is a possibility. So when this is going to be equal to 0, is either the first one is 0, first parenthesis. If that's not the case, then the second one is 0. Then you subtract 4, you get x equals -4. This is where the two graphs meet, or you add 1 here, you get x equals 1. So the answers are -4 and 1. So these are the two places the graph meets. In the second question, there is one student who does the work and he does forget something. Look at this. There is x minus 1 here. There is x and x minus 1. So on both sides, you're supposed to x minus 1 you did here and x minus 1. But the student has forgotten to multiply the x, which is right here. So he did multiply here and he forgot to multiply this x. So this is the mistake he did and which he missed. So by doing so, what this would have crossed out like this, see? And here x minus 1 would have gone away, and what you will be left is x into 2x minus 3 equals 2. So this is what, so he missed that x, see? Now you can use the distributive property like this, equals 2, and then subtract 2 both sides, you get 2x squared minus 3x minus 2 equals 0, and now there's a 2. It's not just a 1, it is 2. So we'll have to use the trick 2x, 2x, and then divide by 2. And 2 times -2 is -4. So what are our option is 1 times 4 is 4 and 2 times 2 is 4. But which is the best bet here? There's a -3. You can see that -3. So I would put -4 here and plus 1. So this is best bet because plus 1 and -4 is -3. So use this 2 plus 1 and -4. So you put plus 1 and -4. And then you put equal to 0. So eventually the bottom denominator 2 crosses out. So divide this to 1 times and 2 times. So you get 2x plus 1 and x minus 4 equals to 0. And you can either say this is equal to 0 or x minus 4 equals to 0. And you can subtract 1 and you can work this out and you know the answer. Question number 3 has another 3 problems. All you're supposed to do is, what are the values of f that makes the equation true? So if this is the case, the first one equals, this means you multiply x on both sides. So you're multiplying x both sides. That way this x crosses out. X times x is x squared equals 25. And then take square root both sides. But when you take the square root, be careful there. You have to write x squared is, when you put this one, then you have to put square root both sides, but you have to put plus and minus. So this equals x equals plus minus 5 because 5 times 5 is 20. So the two answers are x is plus 5 and x is minus 5. See the second question? This is over 1. So you multiply these two together. So that means x plus 2, you multiply x. And the 1, when you multiply this side, the 6x minus 3 stays the same. And use the right distribution, which is x times x squared, and then 2x. So just a regular algebra here, and everything should be taken on the left side. So subtract 6x, and also add 3. So the left side will be minus 4x plus 3 because this together will be minus 4x and the plus 3 stays and this goes away. And now how do this can be factorized because 3 can be written as 3 times 1, right? 1 times 3 is 3 and 1 and 3 adds to 4. But you want to get a -4, so both has to be negative together, together minus 4. So you use the two factors as -3 and -1. This is x. So we can write directly here using zero product property that either x has to be plus 3 or x has to be opposite of plus 1, -1 is plus 1 and you're done. So these are the two values for where the graph, they cross each other. You see the third question is, let's see, the third question is, we can use the cross product here. See, x times x is x squared. And when you multiply 3 times x is 3x squared. Now you subtract 3x squared both sides. So this will be x square, and this is 1, so this will be 1, and minus 3 is minus 2x square is 0. Of course, when you look at this, you can see when will this be 0? Of course, this is how we always write. So this become equal to 0, and then you say put a square root for both. Okay, and then x equals plus or minus 0. So doesn't matter because 0 plus and minus is same as just writing 0. So that's the only solution for that. And the last one, oh, there are 3, so I'm done. Okay, how do we do this part is, yeah, the same thing, you multiply this two. So when you multiply x to 6x squared, it becomes 6x cubed. And this will be plus 18x. And then when you multiply this will be 10x cubed. And then now I will do is subtract 6x cubed because 6 is smaller than the 10. We do want to avoid the negative, right? And at the same time also, I will also subtract 18x. So that way this whole thing is 0. And the right side is 10 minus 6 is 4x cubed, and this is minus 18x. And then we can see there is a x and this is 3. So one of the x can be taken. So we can write this as, or we can distribute, write 2 also is divide. So I can take 2x out, and 2x square is remaining, and this is minus 9. 2 9s are 18, right? So we get like this. And now we have to use the zero product property. That means it is 2x and 2x squared minus 9 is 0. So either 2x is 0 or, please turn in your work. So this one, so x becomes 0. And other one you have to add 9 both sides. So 2x squared is 9, and then divide by 2, we'll get x square is 9 by 2, and put a square root, so we get plus or minus 9 by 2. And that's it, one with plus, another one with my minus, or you could also write this as plus or minus 3 and square root of 2. Or you could also write it plus or minus 3 root 2 multiplied by root 2, and root 2 becomes plus or minus 3 root 2 over 2. I think you got it now, right? So in the lesson number 23, all you do is which of this is the identity. Now what is identity means? It should be true for all x values. Like let's see if this is true. X plus 2 is it same as x cubed plus 8? And you can see the best way to show this is I wanted to use the box. This means we can use the so what is x plus? So if I want to know whether it is true, so just use the distributive property. I can write this as x plus 2 and x plus 2. There are 3 of them, right? So each, and then you do this part first using the box method. So you put x plus 2 here, x and 2, and this become x squared, 2x and 2x and 4, and you can see this will be x plus 2, and that will become x squared plus 4x plus 4, and then again use this like this. So this become x squared plus 4x plus 4, and this x plus 2 you could see. And do the same thing. X times x is x cubed, x times this is 4x squared, and x times this will be 4x. And again 2 times this is 2x squared, 2 times this is 8x, and 2 times this is 8, and then combine them. So this will be together, and the other one will be, this will be together. And then we can see the x cube stays the same. So x cube, this together is 6x squared. This is plus 12x, and the number by itself. So this is not the same. See this part? This is not the same. So this is no. And likewise, you have to do this part. So do this part. So suppose you are working on the best is to do the distributive property by box method. I would do the box method to figure out, and each time you have to do this. Let's say if I want to try this, so there is a long one. So you put x and minus 1 right here. That's one. And the other one is x raised to 5, x raised to 4, x raised to 3, and x squared. and x, and then you multiply x times. I think I forgot. I should have written this and made a slight mistake there. This should be written outside. So you need to multiply, write down this x raised to 5 here, x raised to 4, x raised to 3, x squared, and x. So x times x raised to 6, then x raised to 5, then this, and you can see they are all positive here. And then minus, so this become minus x raised to 5. And we want to know what is the answer. Hello. So this will cross out, this also crosses out, this also crosses out, this also crosses over, this stays. So the answer is x raised to 6 minus x, but they gave you x plus. So this cannot be the answer. And likewise, you need to figure this out by making the box. So this is x squared and minus 1, and this will be x raised to 4, x squared and plus 1. So this will be x raised to 6, x raised to 4, and x minus x raised to 4 minus x squared and minus 1. See, like this. And this crosses out, and your answer gives you x raised to 6 minus x squared minus plus x and minus 1. I missed this 2 here, so that crosses out. This also crosses out. So what are you left with is only this, and which is right here. So this is correct. So if you see this, so that means the first two were wrong. This was wrong, but this is correct. Likewise, I want you to try the other three by yourself. Okay, question number 2 says, is this correct? So all you do is you use the distributive property. Now, what does this basically means? We need to know what is this first. So there is a 2n, so it means it is 2 of x plus 1 and x plus 1. And the right side is 2x plus 2 and 2x plus 2. So you can use this x plus 1 like this. So x and x is x squared. This will be x, this will be x, and this will be 1. So and then you can combine this and you get x squared plus 2x plus 1. But there's a 2 outside which gets multiplied, right? So when you multiply 2, you distribute this and you get 2x squared plus 4x plus 2. That's the left side. But the right side, we have to use this again, 2x plus 2, 2x plus 2. So 2x is 4x squared. 2x times 2 is 4x. 2 times 2x is 4x, and 2 times 2 is plus 4. And then combine the like terms. So your final answer becomes this 4x squared stays the same. This together is 8x and plus 4. But are they same? No. So this is the reasoning is using the distributive, the left and the right is not the same.